Solve linear systems graphically. Question 8. Solve the given linear system graphically. Y equals to 2x minus 1 and 4x minus 2y equals to 6. Now when we say solve linear systems, it means that we have at least two lines, right? Both are linear, correct? So in all the examples which I have taken so far, we will always consider two lines. That forms a system. System is more than one. It could be three also, right? So I'm not complicating the matters at the moment. So we are just taking two straight lines. So that is the system we are dealing with. Now these two lines can intersect at one point when they are not parallel, or they may not intersect at all if they are parallel, right? Or they may intersect at infinite number of points when they're overlapping. These are three different scenarios. Now let's see, where does this fall, right? It's kind of different, and therefore I gave you this background. Now here we have a line y equals to 2x minus 1. It is in slope-intercept form. The best way to sketch is go to the y-intercept, which is minus 1. That's the first point. And then find other points using slope. Slope is 2. That means rise of 2 and run of 1. So we should think like this, right? Slope m is 2, like 2 over 1. That is rise over run, right? The ratio is 2 is to 1. So we'll go 2 up and 1 right. So that is 1, 2 up, and then 1 right. So let's say 1 right. And we get another point, and let this point be here. Correct. So we got 1 point. Again, let's get few more points. 2 up and 1 right. So we get 1 more point. 3 are enough. Let's use these points and draw our line. So here is the line which connects the 3 points. Graphical solutions may not be very accurate, because sketching lines is kind of tricky. If I moved a bit here and there, line will go way off, right? And it could. Now this is our first line. Now the second one is, let me write down here the equation, which is y equals to 2x minus 1. The next line is 4x minus 2y equals to 6. As you have learned by now, the best way to sketch this line is by finding x and y intercepts. So let's find x-intercept for this line. So x-intercept means what? X-intercept means wherever line crosses x-axis. At that point, y is equal to 0. So let's hide this y away, put it 0. We get 4x equals to 6. So we get 4x equals to 6, and therefore x equals to 6 over 4, which is 3 over 2. 3 over 2 is like 1.5, 1.5, correct? So we can plot this point on our graph and see where it is, and that is the x-intercept. You can write x-intercept as 3 over 2, 0, because y value is 0 at x-intercept, correct? So that is the x-intercept, and the point is 3 over 2, which is 1.5, so 1.5 right here in the center of 1 and 2. So we get our x-intercept. Now let's try to find what is y-intercept. So y-intercept is a point where x is equal to 0, correct? Now if x is 0, in this equation, then we get minus 2y equals to 6. That means y equals to 6 divided by minus 2, and that gives me minus 3. So minus 3, and the point basically you could write as 0 minus 3, correct? 0 minus 3 is this point. And if I join these two lines, what do I get? Let me join them and see where do they meet. Well, I'm trying my best to make them meet somewhere, but it seems that they are not going to meet at all. As you can see, these lines are parallel, correct? Since they are parallel, they are not going to intersect. And we say, well, this kind of system has no solution. No solution because they don't really intersect at any point. There is no point where both will have a common point, right? Therefore, there is no solution. But how could you show that? Well, graphically we have seen it is so. Algebraically, let me write down this equation in slope-intercept form and then see what exactly it is. So let's simplify or reorganize, rather isolate y. So slope-intercept form is basically isolating y. So we'll take x on that side, so we get minus 2y equals to minus 4x plus 6. We'll divide with minus 2, and so we get minus 4 divided by minus 2 plus 6 divided by minus 2, and that gives us 2x minus 3. So 2x minus 3 and 2x minus 1. So what is common between the two? The slope, you see, slope is common, and both lines have slope equals to 2, right? Line 1 and line 2. Since the slopes are same, they are parallel, right? And another important thing is that their b, the y-intercepts, are different. b is 1, y-intercept is 1 for the first equation, and y-intercept is minus 1 for the first equation and minus 3 for the second. Since their y-intercepts are different and slopes are same, the lines are parallel. If these would have been same also, then they would have overlapped and they would have had not no solution but infinite solution, correct? That's how it is. I hope you understand the concept of parallel lines and coincident lines. Parallel lines are the lines whose slope is same but y-intercept is different, and that's kind of very important. Thank you.